problem 1.50 or 2.33 for the given thermodynamic books, but for reference please look at the information below. In this problem there is a water in a tank which is pressurized by air. In this the pressure is measured by a multi-fluid manometer, which is shown in the figure. We need to determine the gauge pressure of the air if the values of H1, H2 and H3 are provided, as well as the densities of water, oil and mercury. We have a list of the known values, what we need to find, and for the assumptions we are going to assume that the air pressure is negligible. Therefore we're going to evaluate the pressure at point 1 as shown. In this problem we're going to evaluate the pressure at point 1 by using the value of pressure at point 2, the different densities of the three fluids, and the distances between their interfaces. So we simply write the pressure at point 1 is equal to P2 plus, we start at this point, we go from here to this point, we're going down in elevation, therefore the pressure increases, that's why we have a plus, and then we simply set gamma of mercury times the distances in between them, which is H3. Then we go from this point to this. Notice that we're going upwards. Because we are going upwards, the pressure goes down, therefore the value is negative, and we multiply by gamma of the fluid, which is oil, times the distance in between, which is H2. Then we go lastly from this point to point 1. Once again we go upwards, therefore the pressure is reducing and the quantity is negative. We go gamma of water times H1. Since we have density, we're gonna replace gamma by the density of the fluid times the gravitational acceleration. P1, the pressure at point 2 is 0 because we have gauge, what we're looking for is gauge pressure, plus density of mercury times gravitational acceleration H3 minus density of oil times gravity H2 and density of water and H1. Therefore P1 is equal to gravity, we're gonna factor it out, density of mercury minus density of, this is H3, density of oil times H2 minus density of water times H1. Then we go P1 is equal to 9.81 meters per second square, and then the density of mercury is going to be equal to 13,600 kilograms meter cubed. The value of H3 is equal to 0.4 meters minus the density of oil is equal to 850 kilograms per meter cubed. The value of H2 in this case is equal to 0.3 meters. And then lastly, the density of water is 1000 kilograms per meter cubed. And the distance in between is H1, which is 0.2 meters. If we multiply all these values, we find that the pressure of 1 is equal to 48902.85 pascals, or we could convert it into kilopascals and gives us 48.9 kilopascals. Please note that the value of this pressure is gauge, since we are taking the value of pressure 2 to be 0. If they had asked us to calculate the absolute value, P2 would have been the value of the atmospheric pressure at that particular point.